Okay, this is the last page of the note spiral as far as notes. So chi-square test of homogeneity. This is scenario 3, page 235. So one random sample, so we have a random sample, indicates that the number of televisions that American families have is distributed this way. And it follows this. And so they did a sample, and we don't need this percentage, all right? That probably shouldn't be there, but they did this collection from the sample and got 60, 96, 330, 96, and 48. Then the second random sample is in the far western United States and recorded in this data. Now here's the deal. We actually have two random samples. And you're like, this is just like that problem we already did. And so let's go back and look at our note spiral and turn to page 221. And it's the problem is similar. So we're going to look back at page 221. So do that for just a moment. And you're like, see, there's the televisions. Here's the difference. This had a single random sample. Here we have multiple samples. Because this was a single sample, we only could do, because it was a single sample, this was a chi-square goodness of fit test. Because they wanted to know if it was different. Here, yeah, they want to know if it's different, but we have multiple samples. And so we have, okay, we have two frequencies. And consequently, we essentially have a 5x2 matrix because we have 1, 2, 3, 4, 5 rows and 1, 2 columns. These are not expected values. This is what we actually sampled from two samples. So this is not expected values. Because we have multiple samples, this is going to be, we have multiple samples, we have multiple populations. This is a chi-square test of homogeneity. So at the 1% level, does it appear that the distribution televisions are the same in the far western as in the US as a whole? Looks almost, it sounds the same. The difference again, please notice, more than one sample. So null hypothesis. The US proportion of US or proportion the US and the West have the same proportion of TVs. HA. I really didn't, per household. Or the same distribution. The US and the West have a different proportion of TVs per household. And that may not be the best phrasing, kind of struggled with it there. But this is equal, different is not equal, so we consistence there. Condition 1, independent random samples given. We have two of them. Independent random samples given. 2, we have in this case, what's our sample size? Well, I need to add up all these together. So let's add them all up. And so we have 60 plus 96 plus 330 plus 66 plus 48 plus 66 plus 119 plus 340 plus 60 plus 15. 1,200. So 1,200, 1,200 divided by 0.1 equals 12,000. Reasonable to assume there are more than 12,000 families. N is less than 10% of the pop. Number 3, expected value. Expected values are greater than or equal to 5. See table. Actually, tables in our case. We'll come back and we'll do that in just a moment. Observed values are counted data. That's whole numbers. So we need to enter this into the matrix to find out what our expected values are. So second matrix, and by the way, I've already done this. And I press edit, and I have 1, 2, 3, 4, 5, and I have 2 columns, 1 and 2. And here's 60, 96, 330, 66, and 48 in the first column. In the second column, it's 66, 119, 340, 60, and 15. So we're going to go ahead and run this thing. So second matrix, edit, second quit, stat, test, chi-squared test, calculate, and we get an extreme chi-squared value. We get a chi-squared equal to 20.466. Degrees of freedom is going to be 5 minus 2 times 2 minus 1. 5 minus 2, 5 minus 1, excuse me, 5 minus 1 times 2 minus 1. So this is 4 times 1. So our degrees of freedom is 4. And our p-value equals 0.0004. So let's go back and check our matrix for expected values. My expected value for here is 63. Then I get 107.5. 330 is 335. Here I have an expected value of 63. And for 48, I have 31.5. For this one, I have 63, 107.5, 335, 63, and 31.5. Notice the expected values are exactly the same because I have 2 columns. And we're testing to see if they're equal. All right. So our chi-squared formula, chi-squared equals observed minus expected squared over expected, which in this case is 60 minus 63 squared over 63 plus plus 15 minus 31.5. We already said that gave us an extreme chi-squared, and our chi-squared is 20.466. 6. And if you forgot where that came from, let's run that real quickly. Stat test, chi-squared test. There's our 20.466, and our p-value is 0.004. And alpha is 0.01, because that's what they said use. This is less than, so we reject the null. Now, please remember, I can still calculate that. Second vars. Oops. Chi-squared CDF. 20.466. Degrees of freedom is 4. And there it is, 0.00043. All right. So, our conclusion. Our p-value is 0.004. We reject the null. There is sufficient, in other words, we have lots of evidence to suggest that the US as a whole has a, has a different proportion, has different proportions of TV ownership as compared to the West. Our p-value is 0.004. We reject the null. There's sufficient evidence to suggest that the U.S. as a whole has a different proportion of TV ownership as compared to the West. Simplified. U.S. and West have different proportion of TV ownership per house. Per household. All right. Now, once again, this one differed from our previous one, although it was exactly the same problem. The first one said it was a single sample of 600. So we're comparing to the past. Here we have two samples, and because we have two samples, we have a chi-squared test of homogeneity. All right. In my opinion, what shows up most on the AP exam is chi-squared test of independence, followed by chi-squared test of chi-squared goodness of fit test, followed by chi-squared test of homogeneity. Homogeneity does show up, but it isn't frequent, not nearly as frequent as the other two. So first comes chi-squared test of independence, then goodness of fit, then homogeneity. All right, and do your best. Always look for the number of rows and columns. If you have more than if you have more than 2 rows and more than 2 columns, it's not going to be a goodness of fit. With a goodness of fit, you're going to have at least, either in the rows or in the columns, you will have to have 1 row or 1 column, whereas the other one will be multiple values. Again, independence and homogeneity will have more than 2 rows and more than 2 columns, or 2 or more rows and 2 or more columns. Homogeneity will have more than 2 or more rows and 2 or more columns. Independence, 2 or more rows and 2 or more columns. Goodness of fit, one of those, either the rows or the columns, will have to be 1. All right, good luck. Thank you.